Hi, my name is Jacob Pollock.
I'm Jacob Wilker. Together we designed and produced a thread-driven nail puller that uses the power of Acme threads to remove fasteners from wood.
Now the reason that we wanted to design this Extract Me is to remove fasteners such as framing nails or trim nails from a wide range of materials in a way that wouldn't damage the wood or the fastener, as well as being much more versatile and faster. So how this design works is we have a threaded Acme rod with a hex head, and that hex head is going to be driven with an impact gun such as this. And as we back this threaded rod up, this head can comes inside of the exterior collar, and on the end of that can is where the head of the fastener sits. And when we back the rod up, the can comes inside of this collar, and the shoe of this exterior collar is what comes in contact with the material. So when you're backing this rod up, in order to prevent this can from spinning with the rod and completely shearing off the head of the fastener, we had to put in the design a pair of thrust bearings, and those will sit on both sides of the can with threaded shaft collars fixed at the end of the Acme rod. And how this works is when we're backing the Acme rod up out of the collar, it lifts the can up, and the threaded shaft collars will spin with the rod, but these bearings will allow the can to stay stationary once there's a vertical force being pulled in the opposite direction from the fastener.
As Jacob went over, the intent was to use the tool to remove fasteners from wood cleanly without any damage, and to do that we would be pulling strictly on the head of the nail in the Y direction instead of other usual tools to pull nails like a flat bar or the end of a hammer would pull in both the X and the Y direction, which can result in damage to the fastener and to the wood. The tool is made in such a way with set screws at the top to where the whole tool can be disassembled and can be cleaned and oiled and maintained. The shoe at the bottom of the pulling collar is where we get all the surface area to dissipate the force that is pushed down into the wood to avoid damage to the wood. We use the design load of 2,000 pounds to ensure reliability when removing larger nails. And now we can use the tool to remove nails here and compare it to a couple other more conventional tools to remove nails.
So what we have here is a standard common pine board used for trim, either on baseboard or around a door. And these fasteners are going through the pine drywall and then into a 2x6 stud behind it. So the standard way to pull a fastener such as this would be using a flat bar. And how this works is you would wedge the head of the nail into the flat bar and apply a lever that pulls the nail out as well as down. Now the issue with this is that not only does it detent this wood right here, but it makes the hole a lot larger than it needs to be, as well as bending the fastener, so there's no chance of it being reused. Next, I'll use the Extract Me to pull an identical nail from the pine board. So you put the head can onto the nail, put the impact gun on the hex head, and just back the rod straight out of it. And the reason that this tool works better than any other solution is that it leaves the board completely untouched, the hole at a minimal size, as well as not bending the nail one bit, so it can be reused as well as the board. So one issue that we have run into when using this tool is that when you're going from fastener to fastener, you would put this rod back down And the issue with that is that once you're lined up to go on to the next nail, you don't know where this opening is. So one solution that we could possibly incorporate into this is installing a sort of rail system inside of the collar, and a key that would be at the top of this head can that would slide into the rail system, and that would keep this collar or the head can at the same position the entire time, so you don't have to spin it around to get it lined up with the next head.
We also had one small issue with knowing when we're at the top of the thread range. In here on the threaded clamp, we actually jumped a thread. If you're using an impact, it could possibly just skip a thread down.
So the one way we could take care of that is to apply a sort of marker on the exterior of the Acme threads so that the user is aware of when he's about to run out of threads, and he will see the mark, and that will prevent the collar from hitting the top flange. Thank you.
Thanks.